Hello students, our today's topic is Hofmann reaction. This reaction is also known as Hofmann rearrangement reaction. This reaction is also called as Hofmann bromamide reaction, and it is also known as Hofmann degradation of amide. All names can be used for this single reactions. So let us look at the general reaction of this rearrangement. In this reaction, the starting material is amide, which have the formula RCONH2. The amide on reaction with 4 moles of sodium hydroxide in presence of bromine undergoes a reaction whereby we get formation of this product RNH2 along with formation of 2 moles of sodium bromide, 1 mole of sodium carbonate and 2 moles of water molecule. The product obtained here is called as amine. So if we look at the starting material and the final product, we can guess some important things. First thing is that the amide used here is primary amide. Though none of the hydrogen of this NH2 group are replaced by any other alkyl group, we will call it primary amide. So please keep this point in mind that the starting material is primary amide and it gives formation of this amine, which is very important one, and it is called as primary amine. So ultimately this reaction is used for conversion of primary amide to primary amine. So let us look at some classical example of this reaction. So let us start with the first example. CH3CONH2. It is called as acetamide. In IUPAC name, it is called as ethanamide. So when ethanamide react with 4 moles of sodium hydroxide in presence of bromine, there is formation of this product which is called as methanamine. There is liberation of 2 moles of sodium bromide and sodium carbonate and 2 moles of water molecule. We just have to look at the starting material and the final product. The initial compound acetamide consists of 2 carbons. The final product methanamine consists of only 1 carbon. That means by this reaction a 2 carbon compound is degraded to 1 carbon compound. That's why this reaction is called as Hofmann degradation of amide. Now you may surprise that why this reaction is called as Hofmann rearrangement. So if we look at the starting material and the final product, we will find that In the starting material, this alkyl group is attached with carbon. In product, the alkyl group is attached with nitrogen. That means this alkyl group rearranges its position from carbon to nitrogen. That's why this reaction is called as Hofmann rearrangement reaction. Now let's look at some other examples. The second example is this one, where the starting material is a 3-carbon amide, which is called as propanamide. This consists of 3 carbons in total. So when we start with propanamide, the product obtained is this one, which is called as ethanamine. The ethanamine consists of 2 carbons. In this compound, the alkyl group is the ethyl group. So ethyl group is migrated from this carbon to this nitrogen into the product. So there is loss of 1 carbon. In starting material, there are 3 carbons. In the product, there are 2 carbons. So once again, it is degradation of amide. Now let's look at the next example, where we are going to use an aromatic aryl group. So let's start with this structure. Now in this case, this alkyl group is a phenyl ring. The starting material is called as benzamide. From benzamide, we will get the product where the phenyl ring is going to be directly attached with the nitrogen to give this product. This is called as aniline. So benzamide in total consists of 7 carbons. In aniline there are only 6 carbons, and that are of only the phenyl ring. So in this way, the degradation of benzamide takes place to give us the aniline. This is the primary amide, and this is the primary aromatic amine. Let's look at another example. This starting material is called as nicotinamide. Here the heterocyclic ring present is a pyridine ring. When nicotinamide undergoes Hofmann rearrangement reaction, it gives formation of this compound, which is called as 3-aminopyridine. So conversion of nicotinamide to 3-aminopyridine is also a classical example of Hofmann rearrangement reaction. Now let's move on to the next and the last example. This example has its industrial use. The starting material is this one, which is called as phthalimide. The phthalimide, on reaction with NaOH and bromine, undergoes the Hofmann rearrangement to give us the product like this. Here one of the imide bond undergoes degradation to give us this product, and this product is called as anthranylic acid. So these 5 are very classical examples of Hofmann rearrangement reaction. Let's see how the mechanism of Hofmann rearrangement takes place. In this reaction, there is use of sodium hydroxide along with bromine. When sodium hydroxide mixes with bromine, it gives formation of sodium bromide, sodium hypobromite, along with formation of water molecule. Dear students, this is very important point to remember, that the sodium hydroxide with bromine gives formation of sodium bromide and sodium hypobromite, which is the reactive species which is actually involved in the Hofmann rearrangement reaction. So when our starting material RCONH2 reacted with NaOH and bromine, there is ultimate liberation of sodium hypobromite, from where we will get the hypobromite ion, which is written as OBr negative. As there is a positive charge on sodium, so OBr will acquire the negative charge. Now if we look at this bond between oxygen and the bromine, both have the electronegativity difference, due to which the electron pair of this bond are attracted towards the more electronegative oxygen, while the bromine will acquire the delta positive charge. The hydrogens which are attached with this nitrogen are acidic now. That means these hydrogens can react with a base. So the hydrogen which is attached with this nitrogen can be taken by the oxygen of hypobromite. So when hydrogen removed from here, it will donate its pair of electron to the nitrogen. So this hydrogens, these electrons are available with the nitrogen now. So bromine, which is electron deficient in this species, will attack over here to grab these electrons. So in this step there is formation of this species along with formation of the hydroxide ion. Now if we look here, this species is called as bromamide because bromine is attached on the amide. So this species is bromamide. So bromamide and this hydroxide ion again react. Again these acidic protons are given by this amide and there will be release of water molecule. So with release of the water molecule, we will obtain this species. When hydrogen is detached from here, this electron pair are now available with this nitrogen. So this nitrogen will acquire the negative charge. So this species is called as bromamide anion. This is very important species, bromamide anion. If we look at this species, we can find that this nitrogen has a pair of electron over here, so it will try to make a bond with this carbon. So we get formation of this intermediate species. Now the actual rearrangement takes place at this level. This electronegative bromine attract the electron pair toward itself. So nitrogen will be electron deficient now, and in this condition it will acquire the character of nitrine species. That means it is electron deficient, and to fulfill its deficiency, this electron releasing alkyl group try to migrate from the carbon to the nitrogen. So this alkyl group as R negative, means with pair of electron of this bond, will migrate over this nitrogen. When the bond between this carbon and this alkyl group is going to be broken down, the bond between this nitrogen and this bromine has to be broken down. So ultimately this negatively charged alkyl anion substitute this negatively charged bromine. So you may consider it as intramolecular nucleophilic substitution reaction. So when this substitution takes place, we will get the detachment of bromine from here as Br negative. The alkyl group will make a bond with this nitrogen, and this oxygen with its pair of electron will make a double bond with carbon. So in this condition, we will obtain this product. This product is very important one, and it is called as alkyl isocyanate. The alkyl isocyanate then reacted with water molecule HOH, the hydrogen, so this will be the, there will be the change. The alkyl group is attached with the nitrogen, so it is R and double bond C, double bond O. It is called as alkyl isocyanate. So when alkyl isocyanate react with water molecule, we may assume it as HOH. The hydrogen will go on to the nitrogen, while the hydroxyl group will go on to the carbon. So this gives formation of RNH C double bond O OH. This is called as carbamic acid. So being acid, the proton is transferred from this hydroxyl group to the nitrogen, So when hydrogen is transferred from the carbon to the nitrogen, this oxygen tends to make a double bond with this carbon. So it will form a CO2 molecule. When CO2 molecule is formed, this bond between this carbon and this nitrogen will be broken down. So here at the end we get formation of carbon dioxide along with formation of RNH2. So here we get the formation of primary amine. The carbon dioxide so form react with water molecule to form H2CO3, which reacted with sodium hydroxide to give us formation of sodium carbonate. So in this way, starting with amide, we get the final product primary amine. So that is all about the introduction and the reaction mechanism of Hofmann rearrangement reaction. Please like the video, share it, and don't forget to subscribe. Thank you.